22 years after Juan, tracking forest recovery in Point Pleasant Park. Hello, my name is Brianna. I'm going to be going over the introduction, starting off with Point Pleasant Park and Hurricane Juan. So in this experiment, we got to go to Point Pleasant Park, a 185-acre urban forest surrounded by the Atlantic Ocean at the eastern end of the Halifax Peninsula. But most of us would recognize it for its incredible walkways and black rock beaches. So Point Pleasant Park is an Acadian forest containing various species that we would have observed during this experiment, including red spruce, white pine, red maple, and various others. So prior to 2003, most of the forest was considered an even age because of the historical planting and management. This area is also known for its shallow soils and shallow root systems, making trees extremely vulnerable to harsh conditions such as a hurricane. So going into Point Pleasant's rich history, it started off as a significant Mi'kmaq gathering place known as Amatukati, signifying a spiritual place. This is also where they would go and have their summer fishing camp. It then turned into a military base for British defense from 1749 until 1929, and then again from 1939 until 1945 during the Second World War. So throughout this time, the forest underwent continuous biomass extraction and tree disruptions. So Point Pleasant turned into a recreational area in 1866 as what we have it now. So Hurricane Juan happened on September 29, 2003. This hit Halifax, affecting areas from the Shad Bay until the Prospect of Halifax municipality. This was a Category 2 hurricane with winds up to 160 kilometers per hour, causing over 70% disruption to Point Pleasant's trees and ecosystems. So this caused a secondary succession. Okay, now let's go over secondary succession and what that looks like. So because soil was not fully removed during Hurricane Juan, regrowth followed a secondary succession pathway, with various succession patterns observed, such as increased richness and diversity, changes in species dominance, increased tree density and average size. And for all of these reasons, this is why we get to investigate Point Pleasant Park. Okay, so the goal of this experiment is to investigate how Point Pleasant Park forest communities have changed since the 2003 Hurricane Juan. We predict that the density, richness, and diversity will all increase as more species establish over time. We also expect that the average tree diameter, known as DBH, will also increase as the forest matures.
The data was collected in October from 2004 to 2025 at Point Pleasant Park in the wake of Hurricane Juan across 6 replicate sites, each chosen due to their high level of disturbance. Data about the process of succession was taken on trees by measuring the diameter at breast height, 4.5 feet off of the ground, of all living trees at least 2.5 centimeters in diameter, measured using a diameter tape. Ground flora was measured by taking the percent cover of each species using a 1 meter squared quadrat in 12 areas per site, selected by blindly throwing an object and measuring the area it landed in. Using that data, the percent cover over the whole site was then estimated by consensus. We then analyzed this data in 5 different ways. We found the density of each site and the density of the dominant species red spruce and red maple to study changes in dominance. We found the average DBH of the trees at each site to study changes in age. We calculated species richness, S, by taking the number of unique species per site. We calculated the diversity of the sites using the Shannon index, H, and we found the evenness, J, as defined by below. We then analyzed the trends of all of our results on each site every year using linear regression on a scatter plot, which was chosen due to the 6 replicate sites' independence from each other to view the trend of the changing values throughout the years.
These tables displaying the results will be referenced in the following slides. Okay, so now we're going to talk about how the overall forest community has changed over time since the 2003 Hurricane Juan. So if we look at the regression analysis results, we can see that the total density has significantly increased. This would suggest that there's been a rapid increase in new trees in the area. Moving on, we go on to species richness. This has also experienced a significant increase, which would suggest an increase in species like more different species in the area that established within the park. As a result, this also reflected in the Shannon diversity with an increase in that as well. So the only thing that we did see a decrease in was the average size, or the DBH, in trees. This was likely due to all of the new growth that would have a smaller diameter. These aren't the expected values, but for that time, and since they're such new trees, this data makes sense. The other thing that we saw was a shift in the dominant species. So red spruce density significantly decreased, while the red maple density significantly increased. Okay, so what we know about secondary succession, this forest community should be moving towards a mid-successional habits, and then eventually a climax community. So in this climax stage, we can have 4 predictions. The first one being that the total density will peak, then experience a decrease due to the increase in competition. So naturally, individual trees will grow larger than others. So there's going to be your larger trees and then your smaller ones, which will be weaker, resulting in self-thinning. The other prediction we have is that species richness, Shannon diversity will both likely peak in the mid-succession phase and also experience a slight decrease due to competition. The next prediction we have is the average DBH will be seen to have a significant increase from the data collected in this experiment as the new growths have turned into mature trees. So in the last slide, we saw that the DBH actually decreased, but over time, especially once we approach that climax stage, the DBH is going to increase as the trees in the forest matures. So the last prediction we have is that dominance will shift again, and the red spruce will experience a slower increase rate rather than the red maple. And this is solely due to shade tolerance. So the red maple is more shade tolerant than the red spruce, which will favor the growth of the red maple more than the red spruce.
Our objective was to use linear regression to analyze the trend of density to answer the question, how have the densities of the dominant species changed over time? Our hypothesis was that the density of red spruce would increase slower than the density of the red maple. We used linear regression analysis to examine the change in density of the red spruce in sites of high disturbance to better understand the process of succession in the Acadian forest. The slope of the linear regression in figure 2.1 suggests that there was a density increase of 0.35 red spruce per site per year, and that there is a weak yet significant relationship between the passing of the year and the increase in density of red spruce. We also used linear regression analysis to examine the change in density of the red maple in sites of high disturbance to better understand the process of succession in the Acadian forest. The slope of the linear regression in figure 2.2 suggests that there was a density increase of 2.25 red maple per site per year, and that there was a weak yet significant relationship between the passing of the year and the increase in density of red maple. The slope of the regression of the red maple being much larger than the red spruce heavily supports our hypothesis. The red spruce was only dominant for a short time following the hurricane, 2004 to 2009, because of its role as a late successional softwood. In the secondary succession model, this surviving species was left over from the park's original tree composition of around 80% softwoods. The red maple became dominant in 2009 onward and colonized the exposed canopy at a rate much more rapid due to the species' role as a sun-loving competitive hardwood. The 5-year gap between disturbance and the dominance of the colonizing hardwood was consistent with the timeline of canopy recovery following disturbance as well. As the process of secondary succession continues and the climax community is reached, we predict that the dominant species will once again be red spruce, as the late successional softwood will perform much better than the sun-loving red maple once the canopy has been developed and the red maple is shaded out.
Hello, my name is Maya, and I will be answering the third question on how has the chosen community metric changed over time, why, what would you predict will happen to the chosen community metric as the forest moves towards its climax community, and why. A chosen community metric is a measurement used to understand how a community is performing, growing, and engaging over time. It also helps us indicate whether a community is healthy, active, and growing to meet its goals. The chosen community metric for this study was diameter, and diameter is a standard easy-to-measure indicator of a tree's and age-related growth. Measuring the same trees over time can reveal an increase in diameter, indicating a maturing forest. Continuing with the last slide, as the forest matures, it becomes more complex and stable, and it helps create layers, making it a better structure, serving as a biodiversity hotspot. A species richness graph helps show the overall species within an area as the forest matures and reaches its climax community. This graph shows species richness versus year, and as the years increase, the species richness increases as well. My prediction for Point Pleasant Park is as the forest reaches its climax stage, which is a stable, self-sustaining community that can maintain itself indefinitely under existing environmental conditions, the tree diameter growth slows and stabilizes, and the forest becomes stable and no longer constantly expands.
So to conclude this presentation, I would just like to reiterate that following the Hurricane Juan in 2003, the Point Pleasant forest communities changed dramatically. We predicted that there would be an increase in density, richness, and diversity as more species establish over time. This was proven with the data. We also expected that there would be an average diameter increase as the forest matures and approaches the climax stage. However, our data shows that there was actually a decrease due to the smaller diameter and new trees. So thank you so much for your time and have a good day.
Now for the questions about our slides. The Mi'kmaq believed that Point Pleasant Park was an important cultural site in their mythologies. Do you think that culture and science should work together to preserve these sites like Point Pleasant Park? For some background information, Point Pleasant Park was traditionally a significant Mi'kmaq gathering place known as a spiritual place or the place of spirits. So, yes, I think culture and science should work together to preserve these important sites. These sites share stories, traditions, and values of past generations, helping communities maintain their sense of identity.
Okay, so when considering how communities can protect against future disturbances on the scale of Hurricane Juan, it's important to understand what triggers their secondary succession. So, major disturbances such as wildfires, floods, volcanic eruptions, or even human-induced impacts such as deforestation are often intensified by climate change. As climate change continues to progress, we can see more extreme weather events such as heat waves, droughts, floods, and even hurricanes such as Hurricane Juan. So, to reduce the risk and severity of future disturbances, as individuals and as a community, we can work towards reducing greenhouse gas emissions to help climate change.
We expect Point Pleasant Park to fully recover from Hurricane Juan. Hurricanes are a part of the natural process of disturbance and succession, the effect of which can lead to healthier forests by creating disturbance marker sites such as pits and mounds. The disturbance event was not so great as to significantly alter the climax community. We expect the climax community to strongly resemble the pre-disturbance community, with high rates of red spruce as well as white pine, especially along the shoreline. We could also expect a small retention of species not typically thought of as late successional filling the niche in these microsites, such as red maple.
We would first like to acknowledge that Dalhousie University is located on the traditional Mi'kmaq territory. We would also like to express our sincere gratitude to the Department of Biology at Dalhousie University and all of the teaching staff, including Joanna and the TAs, for providing the necessary resources to complete this experiment. We would also like to acknowledge the previous students who would have had to collect data at the same sites from 2004 until present, making this long-term experiment possible. Finally, we are very appreciative of all of the conservation efforts that took place following the hurricane, making Point Pleasant what it is today.
These are our references.